Dear students, good morning, good afternoon, good evening. How are you? I hope best for you. I Mukesh Kumar welcomes you to online Mukesh Online Academy. आपका मुकेश ऑनलाइन अकेडमी में स्वागत है. And we are doing the science of class 10 from the NCERT book. And that is the chapter number 13, magnetic effect of current. We are doing physics section. Okay. And we have already covered this chapter into the previous 10 videos in which we have covered about the magnets, magnetic properties, magnetic field lines, activities. We covered about the straight current carrying conductor, coil, solenoid, and in the last video we covered about the electromagnets. I hope you must have seen those videos. If you have not still seen, I have given the links into the description. It is better you watch those videos before watching this video. You know, every video is in continuation with the previous one. Okay. Now one tip. Just take out your notebook and pen. Okay. And write the key points. You know, whenever you are watching the study related video from any person, you should write the key points, make the summary. Okay. And this will help you to revise into the exam. Otherwise, it becomes too much to revise into the exam. And I hope you must be following that after watching my so many videos. Okay. And if you have any doubt, if you have any query, you can always write to me on the WhatsApp or email. So we will be happy to solve your queries. And I hope you must be getting knowledge from my videos. You must be getting good marks from my videos. Okay. Kindly share it with your friends. Subscribe to it. And if you want to get the notes of each and every chapter free of cost, then write to me on the WhatsApp or email. So we will be happy to provide you. Okay. And in this video, we are going to do the questions. Based on that, we have studied the straight current carrying conductor, coil, solenoid. So we will be doing the questions on that. Okay. So in this video, we will be doing the questions on straight current carrying conductor and the coil. Okay. So now let's do it. So dear students, in this video, we will do the questions based on the current carrying conductor, coil and solenoid. Okay. In the last three videos, we have studied about the straight current carrying conductor. We did so many things about them in the coil and the solenoid and electromagnets. Now we will do the questions. There are some questions which are left. Now we will cover those questions into this video. So the first question we have, show that the magnetic field produced by a given electric current in the wire decreases as the distance from the wire increases. Okay. So this question is related to the factors which affect the magnetic field in a current carrying conductor, straight current carrying conductor. Suppose this is the wire. Okay. One distance is this, other distance is this, other distance is this. Okay. Suppose this is the R, P1, P2 and P3. Okay. So we have to show that magnetic field produced by a given conductor, given electric current in the wire decreases, means the deflection. What we can do to show what they want to see, that we had studied in the factors that as we go away from the wire, the magnetic field reduces. Okay. And as we come towards the wire, means nearer to the wire, the magnetic field increases. So that means if we keep the compass needle at P1, then at P2, then at P3. So the deflection will be maximum at P1 and minimum at P3, and between P1 and P2, the deflection will be less than P1 but more than P3. So it means that by keeping a compass needle at the different points and by just checking the amount of deflection into the compass needle, we can see that the magnetic field is decreasing. We have the second way also. Suppose if we put the iron particles, so that what will happen? The gap between the concentric circles as we are going away from the wire will start increasing. Okay. If we keep one point here, then it will be even more. Okay. So the distance between the gap between the concentric circles, like this is the gap between the concentric circles. This gap will keep on decreasing as we move away from the wire. Okay. So now let's write it. When a compass needle is taken away slowly from the current carrying conductor, the deflection of the compass needle decreases as we move away from the conductor. Okay, this shows that magnetic field produced by a given electric current in the wire decreases as the distance from the wire increases. I hope this is clear to you. Now, what is the second option that we can give here? When iron fillings are sprinkled on a cardboard placed perpendicular to the wire, and cardboard is gently tapped, the pattern shows magnetic field lines which are further apart from the wire. I hope this is clear to you. It means that, what does the second point mean? Suppose this is the current carrying conductor. Okay, now we sprinkle the iron powder here. Okay, now if we tap it, then what will happen? They will just adjust themselves into the concentric circles. Now the gap, as when we are near to the wire, then the gap between the circles will be less, and as we go away from the wire, this gap between the circles will keep on increasing. Okay, so how can we? There are the two ways. Let's repeat it. We have the two ways. If we keep the compass needle at different points, so as we move away from the wire, the compass needle will show the less and less deflection. Or second, we can do it by using the iron flakes. I hope this is clear to you. Now do the next question. Now, the question is, a student performs an experiment to study the magnetic effect of the current around the straight current carrying conductor. The direction of deflection of the north pole of a compass needle kept at a given point near the conductor remains unaffected when the terminals of the battery sending the current in the wire are interchanged. Okay, this is the first statement. What is the first statement? The direction of deflection of the north pole of the compass needle kept at a given point near the conductor remains unaffected even when the terminals of the battery sending the current in the wire are interchanged. What is the meaning of it? What is he saying in this question? Suppose this is the wire and this is connected to the battery like this. Okay, now this is the positive, this is the negative. It means that now the current is flowing from top to down. Now in the next one, what is he doing? Basically, he is changing the terminals of the battery, and now the current is flowing this way. Okay, so what does he say? That if we keep the compass needle here and if we keep the compass needle here, the direction of deflection is going to be the same in both cases. But that is not the case. That means this statement is wrong. So you can say that first statement is not correct or incorrect. Now let's study the second one also. For a given battery, the degree of deflection of the north pole decreases when the compass is kept a point further away from the conductor. Yes. What did he say? Suppose this is the wire. Okay. It is connected to the same battery only. Okay. Now what does he want to say? If we keep the point here and if we keep the compass needle here. Okay. So that means here the deflection is decreasing and here the deflection is more. Means as we are going away from the wire, the compass needle deflection decreases. So this is true. So we can write that second statement is correct. So that means first statement is not correct and the second statement is correct. So they ask you which of the observation of the student is incorrect. So first is incorrect. Now they have to tell the reason. So now we have to write the reason also. So what is the reason here? As we know that from the right hand thumb rule, when we change the direction of the current, the direction of deflection also changes. Okay, so this is the reason that we can write here. So the reason, when the current in the wire flows in the upward direction, okay, then the lines of magnetic field are in anti-clockwise direction. That means like this we will see. This is the anti-clockwise from the right hand thumb rule. Okay. Now, if the direction of current in the wire is in downward direction, then the lines of magnetic field are in clockwise direction. Okay, means direction is reversed. And which rule we have used here is the right hand thumb rule we have used here. I hope this is clear to you. Now let's repeat it. What does the student say? That the direction of deflection remains unchanged even if we change the terminals of the battery. By changing the terminals of battery means if the positive was here, now the positive is here, and this is the negative, this is the positive. Okay, so it means the direction of current is also reversed. When we change the terminals, then the direction of current will also be reversed. So that means when according to the right hand thumb rule, when the direction of current is reversed, then the direction of field will also reverse. Okay, so the first statement is not correct. Second is, for a given battery, the degree of deflection of north pole decreases when the compass needle is at a point further away from the conductor. This is true because as we go away from the conductor, the magnetic field reduces. So the deflection in the compass needle also reduces. I hope this is clear to you. Now the next question. In this question, AB is a current carrying conductor in the plane of the paper as shown in the figure below. This is the question from the exemplar. Okay. P and Q are the 2 points at a distance of R1 and R2 from it. So this is the distance R1, this is the distance R2. Okay. Now what are the directions of magnetic field produced by the point at P and Q? We have to find the direction at P and direction at Q. And if R1 is more than R2, where will be the magnetic field? Will be larger in Y. Okay. So for the first question, what will we do? We will use the right hand thumb rule. Okay. We will suppose this is the conductor. Suppose here the current is flowing in the upward direction. So that means the field will be like this. The thumb we have to keep it up. Thumb, as we have learned, gives the direction of the current. So thumbs will be up. Now you can see the fingers are encircling anti-clockwise. So one point is here, other point is here. So at this point, if we keep it north and if we keep it south, then it will be east and it will be west. So okay, so direction is going like this, from east to west at the P and from west to east at the Q. This is P, it is from east to west, it is going like this, and here it is Q, from this in the west, and from here it will go like this. Okay, so let's write the answer. So number 1, at Q means at this point it is towards east. We can write away from plane of paper. Okay, and number 2, at P, so here it is towards the west. Okay, here it is going like this and here it is going like this. It is towards west means towards the plane of paper. So the overall direction that we can say is the anti-clockwise is the overall direction in the field. Okay. Now the second point is, if R1 is more than R2, that means this distance is more and this distance is less. Just now we have done, okay, as we go away from the wire, the deflection decreases. That means the magnetic field is getting reduced. So that means magnetic field at Q will be more and magnetic field at P will be less. So the second portion, this is the part of the first question itself. Okay. So for the second question, since R1 is more than R2, and we know that the field is inversely proportional to the distance, where R is the distance from conductor. Okay. So that means the field, what is the field? Magnetic field. The field at Q will be larger than at P. And what is the reason? That it is inversely proportional to the distance from the conductor. Okay. So then let's repeat. The direction of field at Q will be towards the east and here it will be towards the west. So that means anti-clockwise direction is there. Since the distance r1 is more and r2 is less, and as we know that the magnetic field is inversely proportional to the distance from the conductor, so the field at q will be more and field at q will be less. I hope this is clear to you. Now let's do the next question. See, this question is from NCERT. It is example 13.1. Okay. What does it say? That a current through a horizontal power line flows in the east to west direction. So what is the direction of magnetic field at a point directly below it and any point directly above it? See, the current through the horizontal, let's say this is the horizontal power line. It is like this, east to west direction. This is the east and this is the west. So that means current is flowing here to here. So that means what we can do, we will just take our right hand and then we will do like this. And here you can see the fingers are encircling like this. So we have to find the direction here also and we have to find the direction here also. If this is east, this is west, that means this will be north, this will be south. So here it is going like this. So here it is going from south to north. So and the above it, it is south to north, and below it, it is north to south, because the direction is this. If we keep the point here, so it is going like this, that means north to south, and we keep one point here, then it is from south to north. I hope this is clear. So now let's write it. The current is in east-west direction. Okay. Applying right hand thumb rule. The direction of field directly below it, directly below the wire, is from north to south. I just explained you how. And then direction of magnetic field directly above the wire is from south to north. I hope this is clear to you. Now let's understand this again. Suppose this is the wire and this is east, this is west, and current is flowing from east to west. So we just put the right hand like this. So the thumb is indicating the direction of current east to west. So one point is here, one point is here. So fingers are encircling like this. Okay. So that means here if we keep it south, then it is north. So above it, it is south to north, and below it from north to south. I hope this is clear. Now let's do the next question. The question is, the magnetic field associated with a current carrying straight conductor is in anti-clockwise direction. If the conductor was held along the east-west direction, what will be the direction of current through it? Name and state the rule applied to determine the direction of current. See, magnetic field associated is within the anti-clockwise direction, and the conductor was held along the east-west direction. Okay, this is the conductor. Suppose if we keep it like this, so if it is clockwise, then it will be like this. If it is anti-clockwise, then it is like this. So that means the anti-clockwise field will be like this. You can see my fingers. Okay, it will be like this. Okay, so that means the current, the thumb is going like this. So that means the current is flowing into the east-west direction. Okay, so then now let's write it. Applying right hand thumb rule. The direction of current is east to west. And now how we have to state the rule also. Okay, for this you can look for my previous videos in which I have given the statement of the whole right hand thumb rule. We can just explain it. What does the right hand thumb rule means? Imagine the conductor to be placed in the right hand. Okay, and such that the fingers encircle the wire. The direction of the thumb gives the direction of the current, and the direction in which the fingers encircle around the wire gives the direction of the magnetic field. So this is the statement that you can write, or you can go to my previous videos. Okay, and here how we have determined the direction of this from east to west. Now the next question. This question is from NCERT book. Okay, and in this question, a current carrying conductor is held exactly in vertical direction. In order to produce a clockwise magnetic field around the conductor, the current should be passed in the conductor. Here what is given? The clockwise magnetic field. See, clockwise. If we keep it like this, then it is anti-clockwise, but we need a clockwise field. So that means the current should be into the downward direction, from top to down. It should come towards the top. So your answer will become from top towards the bottom is the answer to your question. Okay. So your answer is option A is the answer. I hope this is clear to you, because as we know that when the current is flowing top to down, the field is in the clockwise direction. If it is from down to top, towards the top, that means it will be the anti-clockwise direction. And which rule have we used here? Is the right hand thumb rule we have used here. Okay, now that's the next question. Now in this question, a current carrying straight conductor is placed in horizontal plane such that the direction of electric current is from north to south. What is the direction of magnetic field at a point below the wire? Okay, see, a student has placed the conductor in a horizontal direction like this. Okay, and the direction of electric current, this is north, this is south, and we have to find the direction of magnetic field below the wire. Okay, the question is, a current carrying conductor is placed in a horizontal plane such that the direction of electric current is from north to south. Let's say this is the conductor and north to south, this is the direction of current. So that means the conductor we have to place like this. Okay, and this is north, this is south, this will be east, this will be west. Now the fingers are encircling like this, anti-clockwise. It means that at point here it is going from east to west, and from down it is going from west to east. Okay, so you can say above the wire east to west, and below the wire it will be west to east. So this will be the direction of magnetic field. I hope this is clear to you. Now the next question. Now in this question, a thick wire is hanging from a wooden table. An anti-clockwise magnetic field is to be produced around the wire by passing the current through this wire by using a battery. Which terminal of the battery should be connected to the top end of the wire and the bottom end of the wire? Give reason for your choice. We have to find the anti-clockwise, and as we know, for the anti-clockwise magnetic field, the current should come from towards the top. Okay, if it is going from south to north, so that means an anti-clockwise magnetic field will be produced. So that means, suppose this is the wire, we have to have the current like this. So, and the current is always goes to the positive to negative terminal. So it will be positive and it will be negative terminal. Okay, so then the current will be flowing in towards the top, and we will get the field which is the anti-clockwise. Okay, so that means the lower end should be connected to the positive terminal and the upper end should be connected to the positive terminal. So that means the top end connected to negative terminal of the battery and the bottom end connected to positive terminal of battery. I hope this is clear to you. So now let's understand this again. We need a anti-clockwise magnetic field, and we know that anti-clockwise magnetic field is produced if the wire in the current is flowing in the upward direction, means top, south to north. For this we have to connect the bottom end to the positive terminal and the upper end to the negative terminal of the battery. Then we can get this type of field. I hope these questions are clear to you. Now let's do the question on coil. See, we have the question. This is the question from NCERT book. Consider a circular loop of wire lying in the plane of the table. Let the current pass through the loop clockwise. Apply the right hand thumb rule to find the direction of magnetic field inside and outside the loop. See, this is the loop. Actually, now the loop is not like this. Suppose it is now like this. Now it is just lying on this table. Suppose if my hand is stable, then loop is lying like this. Okay, and in this loop the clockwise means this clockwise current is flowing through it. So we have to apply the right hand thumb rule, because this point, as you can see, this point and this point will behave like a straight current carrying conductor. So if the current is flowing like this, so and it is just like this, okay. So if we just apply the right hand thumb rule here, so that means the field is going towards the inside the loop, okay, means the upward field lines will be there. And here also, since it is come down, so field is here like this. So that means inside the loop or inside the table it is going like this, okay, clear. Here we can say that magnetic field lines are perpendicular to the plane of paper, okay. I hope this is clear to you. Now the next question. Now we have the question, what is the nature of magnetic field lines at the points opposite to each other on a current carrying circular conductor? Suppose this is the current carrying circular conductor. So we have to find the nature of magnetic field lines as these 2 points. As we have discussed into this topic also, that these 2 points will behave like a straight current carrying conductor in which the current is flowing into the 2 different directions. Suppose if it is up, then it will be down, okay. So that means here it will be concentric circles anti-clockwise. Here it will be concentric circles clockwise, okay. So now let's write the answer. The direction of magnetic field lines is opposite on both the point, but there will be circular and concentric field lines at both points, okay. See, here also there will be concentric circles, here also there will be concentric circles, but the direction will be different. Here they will be in the anti-clockwise direction, here they will be in the clockwise direction. Or if the current is flowing reversely, then it will become the opposite. I hope this is clear to you. Now the next question. Now we have the question, if you stand in front of a current carrying circular loop such that the current is in clockwise direction, then the direction of magnetic field is towards you or away from you, okay. See, suppose this is the coil. In my front face it is the clockwise, so that means this will be the south pole. The face which I am facing is south pole, then this pole will become the north pole. And as we know that the direction of magnetic field inside the loop is from south to north, and outside the loop it is from north to south. So here they are going like this, and here they are going like this, and the middle it is going like this. So that means the field is away from me, okay. So now let's write the answer. Since clockwise current in the front face, so what does it mean this? So it is a south pole. It means so other face is north, okay. Since the direction of magnetic field is from north to south outside the magnet and south to north inside magnet, so it is away from me. I hope this is clear to you, okay. Now let's do the next question. Now in this question, Meena draws a magnetic field lines of field close to the axis of current carrying circular loop. As she moves away from the center of the circular loop, she observes that the lines keeps on diverging. How will you explain her observation? Okay, see, according to her, close to the current carrying circular loop, this is the circular loop, okay. As we are moving away from the center, this is the center, and as she is going away from the center, then they keep on diverging, means they go like this, and here they go like this. So what is the reason? Okay, and as we have explained into the circular loop, that inside the loop the field is uniform, and field at the center field is uniform and maximum also, because each point contributes to the field, equal field inside it, so that at the center it becomes maximum also and the uniform also. So in the middle it is a parallel line or straight lines. Okay. Now as we are going towards the wire, then these two ends of the wire works like a straight current conductor in which the current is flowing into the opposite direction. So that is why they keep on diverging, because now they are reaching towards the wire. Okay, reaching towards this coil. So that is why they start diverging, but in the opposite directions. Okay. So now let's write it. In the center of loop, lines are parallel and straight. What is the reason? It has maximum field which is uniform. Reason why? Because each point on periphery adds up the field. Okay. Now the next point, as we move away from center, the lines becomes concentric circles with directions changes at two opposite points of diameter, one being clockwise and other anti-clockwise. So lines keep on diverging. Now let's explain this again. See, in the loop, if we are into the center, the lines are straight and parallel. Why? Because every point of this loop is contributing the same field inside it. That is why in the center it is maximum, and that is why it is in the uniform also. That is why the lines are parallel and straight. Now as we are going towards the wire, means towards the coil, means or towards the periphery, you can say circumference, then what is happening at this point also and at this point also, this is behaving like the two straight conductors where the current is flowing in the opposite directions. Okay, so here they will be the concentric circles with the opposite direction. So that is why this is straight line. So as we go towards this point, so this will move like this, and towards this point it will move like this. So that means the lines are diverging into the different directions. I hope this is clear to you. So today we have done questions on the straight current carrying conductors and current carrying circular loop, and in the next class we will do the questions on the solenoid and electromagnets. So dear students, in the next video we will do the questions on the solenoid. Okay, we could not complete these questions, okay, otherwise the video would have been very too lengthy. So we will do these questions on the solenoid in the next video, and we will cover the magnetism in human beings. Okay, so there is a magnetism in human beings also. So why this is present, so we will cover into the next video. Thank you so much for your watching. Write your comments about the video, any query, any doubt about the topic into the comment box, or you can write to me on the WhatsApp or email. Okay, and I hope you must be making the key points. You must be making the summary. You know, making the summary is good for the examination point of view. Okay, and I hope you must be getting knowledge from my videos. Kindly share it with your friends, subscribe to it, ask your friend to subscribe. Thank you so much.